Good morning. Hello. Am I audible? Chat kin लिखे Pankaj, Nasrin. So today we'll discuss about straight line. This is the third lecture on 3D geometry. So write down equation of straight line in different forms. Equation of straight line in different forms. Write down point DRS form. So next page किम जाती? भूली भुला point DRS form. Equation of line passing through a given point x1, y1, z1 and having DRS ABC is given by x minus x1 upon A equals y minus y1 upon B equals z minus z1 upon C. Equation of line passing through given point x1, y1, z1 and having DRS ABC is given by x minus x1 upon A equals to y minus y1 upon B is equal to z minus z1 upon C. Come to the explanation or proof. Suppose this is the line L. There is a point on the line having coordinate x1, y1, z1 and DRS of the line is given ABC. Let xyz be a variable point on that line. Let this line, the point x1, y1, z1 be P and the point xyz be Q. So DRS of PQ are x minus x1, y minus y1 Z minus Z1. In the introduction of three-dimensional geometry, a line can have many sets of DRS, and two sets of DRS of line are proportional to each other. So x minus x1, y minus y1, z minus z1, and ABC are two sets of DRS of the line. Thus, x minus x1 upon A equals y minus y1 upon B equals z minus z1 upon C. Okay. Quickly note it down. Pankaj, Nasrin, is it clear? Hello. Write in the chat box. So x minus x1 upon A equals y minus y1 upon B equals z minus z1 upon C. Let the proportionality constant be R. So this implies x is equal to x1 plus AR, y is equal to y1 plus BR, and z is equal to, sorry. ये अशोक ये मनुक मनुक पेन चलची ମନକୁ ମନ ପେନ୍ ଚାଲୁଛି କଣ ଏଇଟା ଗାଡି ହେଇଗଲା ପିନ୍ଧଲି ଦେ ଭୁଲି ଗୁଲା ବାସ୍ ଏଇଠି କଣ କହିଲ ସେଟା ଏମିତି ହାତଟା ପଳଉଥିବ ଦେଖୁନାହାନ୍ତି ଲାଗିନି ଟେକ୍ନିକାଲ ଅଛି ସାର୍ X minus x1 upon a is equal to y minus y1 upon b equals to z minus z1 upon c. Let the proportionality constant be equal to r. So x is equal to x1 plus ar, y is equal to y1 plus br, and z is equal to z1 plus cr. So coordinates of a general point on the line are x1 plus ar, y1 plus br, z1 plus cr. This is the equation of line in point dr form, Euclidean method. Then write the equation of line in point dr form, vector method. Okay. Then come to vector method. Equation of line passing through a given point having position vector a bar and parallel to a given vector b bar is given by r is equal to a plus lambda b. Come to the proof. This is the line L passing through a given point having position vector a bar, and the line is parallel to another vector, that is b bar. Let r bar be a point on the vector on the line L. Suppose this is point P having position vector a bar. This is point Q having position vector r bar. So vector PQ, that is the displacement vector, is equal to r bar minus a bar. So PQ is parallel to B. PQ is parallel to B. If two vectors are parallel, then this implies one of the vectors is scalar multiple of the other. R minus a bar is equal to lambda times, where lambda is a scalar b bar. This implies R is equal to a plus lambda b, right? Then come, to the second form. Then come to 2-point form. Equation of line, 2-point form vector method, Cartesian method. Equation of line, passing through two given points X1, Y1, Z1 and Q X2, Y2, Z2 is given by X minus X1 upon X2 minus X1 equals Y minus Y1 upon Y2 minus Y1 equals Z minus Z1 upon Z2 minus Z1. This is point P having coordinate X1, Y1, Z1, Q having coordinate X2, Y2, Z2. Let R, X, Y, Z be a general point on the line. So DRS of PQ X2 minus X1, Y2 minus Y1, DRS by 2-point formula, Z2 minus Z1, and the DRS of PR X minus X1, Y minus Y1, and Z minus Z1. These two sets of DRS will be proportional. Thus, X minus X1 upon X2 minus X1 equals Y minus Y1 upon Y2 minus Y1, Z minus Z1 upon Z2 minus Z1. Right? Quickly note it down. Pankaj, is it clear? Nasreen? Okay. Write down a question. Find the equation of line. in vector form passing through a given point two, 3, -1 and parallel to the vector I cap -2j cap plus of 4k cap, and the equation of line in vector form passing through a given point 2, 3, -1 and parallel to the vector I cap -2j cap plus 4k cap. Okay. To come to the solution. So this is the line L passing through the point 2, 3, -1 and the line L is parallel to the vector 2 I cap, sorry, I cap -2j cap, I cap -2j cap plus 4k cap. So position vector of the point, since the coordinates of the point are 2, 3, -1, position vector of the point is 2I cap, position vector of the point is 2I cap plus 3j cap minus k cap. So vector equation of the line is R is equal to A plus lambda B. Thus vector equation of the line is R is equal to A plus lambda, A is 2I cap plus 3j cap minus k cap plus lambda B, lambda into I cap minus 2j cap plus 4k cap. Okay, this is the answer. Pankaj, is it clear? Pankaj? Nasrin? ଆସିବ ଟିକେ ଆସିବେ କି? ଏ ପିଲାଙ୍କ ମେସେଜ କାହିଁ ପଢି ହଉନି? ମେସେଜ ଟା ପଢି ହଉନି। ଓକେ। The next question. In the equation of line, passing through one one two, and the line is perpendicular to two lines having DRS 2 minus 1 3 and 4 1 minus 1. And the equation of line passing through 1 1 2, and line is perpendicular to two lines having DRS 2 minus 1 3 and 4 1 minus 1. This is the question. So come to the solution. Let ABC be the DRS of the let ABC be the DRS of the required line. The given line is required line is perpendicular to two lines having DRS 2 minus 1 3 and 4 1 minus 1. You know, if two lines are perpendicular having DRS A1 B1 C1 and A2 B2 C2, then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So the required line is perpendicular to the line having DRS 2 minus 1 comma 3. So we can write 2A plus 3 minus B, 2A minus B plus 3C is equal to 0, and the line is perpendicular to another line having DRS 4 1 minus 1. So 4A plus B minus C is equal to 0. Okay. So we can solve these two equations by cross multiplications. Right, done solving above equations by cross multiplication. A upon B1 C2 minus 1 into minus 1, that is 1, minus B2 C1. B2 1, C1 is 3, minus 3 is equal to B upon C1 A2, that is 12, minus C2 A1 plus 2 is equal to C upon A1 B2, that is 2, minus A2 B1, that is minus 4, minus of minus 4, that is plus 4. So this implies A upon minus 2 is equal to B upon 14 is equal to C upon 6. This implies A upon minus 1 equals to B upon 7 is equal to C upon 3. So minus 1, comma 7, comma 3 are the DRS of the required line. DRS of required line. Okay. The equation of the line is x minus 1 upon minus 1 is equal to y minus 1 upon oh, Thus equation of line is x minus 1 upon minus 1 is equal to y minus 1 upon 7 is equal to z minus 2 upon 3. Okay, this is the answer. Then come to angle between two lines. D slash W in between two lines. Cartesian form. The angle theta between the lines x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1 and x minus x2 upon a2 equal to y minus y2 upon b2 is equal to z minus z2 upon c2 is given by theta is equal to cos inverse a1 a2 plus b1 b2 plus c1 c2 upon under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. Into the proof, DRS of the first line are A1, B1, C1 and DRS of the second line are A2, B2, C2. So angle between two lines having DRS A1, B1, C1 and A2, B2, C2 is given by theta is equal to cos inverse A1, A2 plus B1, B2 plus C1, C2 divided by under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. Come to special cases. Theta is equal to 0 degree. That means lines are parallel. Lines are parallel. That is A1 upon A2 equals to B1 upon B2 equal to C1 upon C2. Case 2, theta is equal to 90 degree. Lines are perpendicular. A1, A2 plus B1 B2 plus C1 C2 is equal to 0. I hope it is clear to you. Pankaj, is it clear? Nasrin? Okay. ପୂର୍ବରୁ କାଟିଲେ ଆଉ ଥରେ ଶୋ କରନ୍ତୁ ଟିକେ ସାର୍। ନାର୍ଜୋ କଣ କହୁଛ? କୋଉଟା ଶୋ କରିବି ଆଉ ଥରେ? ପ୍ରିଭିୟସ୍ ପେଜ୍? ହ୍ୟାଲୋ? Okay. This one? Then come to point of intersection of two lines. There is no direct formula for the point of intersection like 2D geometry, but there is a method how to find the coordinates of point of intersection of two lines. This is suppose line L1, this is line L2. Suppose the equation of line L1 is x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1, and the equation of line L2 is x minus x2 upon a2 equals y minus y2 upon b2 equals z minus z2 upon c2. Let this proportionality constant be r1 and this proportionality constant be r2. So this is suppose the point of intersection P. So coordinates of point P in terms of line L1 are x1 plus a1 r1, y1 plus b1 r1, and z1 plus c1 r1. And coordinates of the same point P according to the line L2 are x2 plus a2 r2, y2 plus b2 r2, z2 plus c2 r2. Right? Since these two lines intersect for some values of particular values of r1 and r2, these two sets of coordinates are equal. So we can write x1 plus a1r1 is equal to x2 plus सब कौन है लाट के कौन जूम पड़े असला तो हाथ बाजी गला आज दिन रात के प्रश्न पठा पाओ x1 plus a1r1 is equal to x2 plus a2r2. So y1 plus b1r1 is equal to y2 plus b2r2. So on solving these two equations, we can get the value of r1 and r2. Then we have to substitute the value of r1 r2 in the third set of equation, that is z1 plus c1 r1 is equal to z2 plus c2 r2. If the value of r1 and r2 satisfy the third equation, then we can say that the two lines intersect. Either substitute the value of r1 in this equation, you will get the point of intersection, or substitute the value of r2 in this equation, you will get the point of intersection. Right? Is it clear? Nasrin, is it clear, beta? Hello. Okay. Then come to foot of the perpendicular and image. First foot of the perpendicular. This is a line L. There is a point P. Let the coordinates of point P are x0, y0, z0, and equation of the line is x minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. Okay, we have to find out the coordinates of the foot of the perpendicular drawn from point P upon the line L. Let M be the foot of the perpendicular drawn from point P upon line L. We have to find the coordinates of point M. You see, the point M lies on the line x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. Let the proportionality constant be M. So coordinates of the point M are x1 plus AR, comma y1 plus BR plus z1 plus CR. Okay. If we can get the value of R, then we can get the coordinates of the foot of the perpendicular. You see, PM is perpendicular to the line L. This is suppose line L. PM is perpendicular to line L. So DRS of PM, DRS of PM, x1 minus x0 plus AR, y1 minus y0 plus BR, DRS by 2 point formula. Z1 minus Z0 plus CR, right? And the DRS of the line L, DRS of the line L are A, B, C. If two lines are perpendicular, then the sum of the product of their DRS is equal to 0. That is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So we can write A whole into X1 minus X0 plus AR plus B whole into Y1 minus Y0 plus BR plus C whole into Z1 minus Z0 plus CR is equal to 0. On solving this equation, in this equation everything is given, only unknown quantities are. So from this equation we will get the value of R, right? And if you can substitute the value of R here, we will get the coordinates of the foot of the perpendicular. This is the method to find coordinates of the foot of the perpendicular drawn from a given point upon a given line. Pankaj, is it clear? Hello, Pankaj, Nasrin, Narjo, is it clear, guys? Okay. So write down a question and the coordinates of the foot of the perpendicular drawn from the line, drawn from the point 3, 1, minus 2 upon the line x minus 1 upon 2 is equal to y plus 1 upon minus 1 is equal to z plus 2 upon minus 3. This is the question, okay? Solve it and send me the answer. What are the coordinates of the foot of the perpendicular? The coordinates of the foot of perpendicular drawn from the point 3, 1, minus 2 upon the line x minus 1 upon 2 equals to y plus 1 upon minus 1 equals to z plus 2 upon minus 3. Okay, come to the solution. Let the proportionality constant be r. So coordinates up by any point on that line will be 2r plus 1, comma, minus r minus 1, comma, minus 3r minus 2. Okay. So this is the line L. This is the point P having coordinate 3, 1, minus 2. Let M be the foot of the perpendicular. So coordinates of M are 2r plus 1 Nasrin 17 by 6, 16 minus 16 upon 15 minus 7 upon 3. Okay, beta, let me check it. I'll solve it. Okay, 2r plus 1, then minus r, minus 1, minus 3r, minus 2. So DRS of PM, DRS of PM are 2r plus 1 minus 3, 2r minus 2, comma, minus r minus 1 minus 1, minus r minus 2, then minus 3r minus 2 plus 2 minus 3r. Okay, and DRS of the line are 2 minus 1 3. So 2 into 2r minus 2 minus 1 into minus r minus 2 minus 3 into minus 3r is equal to 0. So 4r minus 4 plus r plus 2 plus 3r is equal to 0. 4r plus 3r, 7r plus r, 8r, 8r minus 4 plus 2 is minus 2 is equal to 0, implies r is equal to 2 by 8, that is 1 by 4. Now substitute the value of r here to get the coordinates of the foot of the perpendicular, right? So guys, your first session is over and second session will start exactly at 9. Second session is from 9 to 10. Okay.
ଆଣ୍ଟି ଦେଲ କବାଟ ଟିକେ ବନ୍ଦ କର ମାନେ ଶୋଇପାରୁନି ଲାଟିନ୍ ଲାଗୁଛି ଏକ ଲାଗୁଛି
ଗୋଟେ ଦି
କେତେବେଳେ ଖାଇବ ଏଠି?
Good morning.
Good morning, sir.
Good morning.
Good morning. Good morning. Iba? Mo ano yung pasara porta? Good morning, sir.
Good morning.
Good morning.
Okay. Then come to the image of a point with respect to a line. Image of a point with respect to a line. Let P be the point having coordinate x0, y0, z0. We have to find the image of the point P with respect to the line x minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. Right? Let q xyz be the image of the point x0, y0, z0 with respect to the line. Let m be the foot of the perpendicular. So, as you know, object distance is equal to image distance. The point M is the midpoint of PQ. M is the foot of the perpendicular. So, we know how to calculate the foot of the perpendicular. Let the foot of the perpendicular be alpha, beta, gamma. Then x0, x plus x0 upon 2 is equal to alpha, y plus y0 upon 2 is equal to beta, and z plus z0 upon 2 is equal to gamma. This implies x is equal to 2 alpha minus x0 and y is equal to 2 beta minus y0 and z is equal to 2 gamma minus z0, right? So if you can find the foot of the perpendicular, then using the coordinates of the foot of the perpendicular, we can get the coordinates of the image of the point, right? We have done a question. Find the coordinates of the and the image of the point. Two and 4 with respect to the line. Find the image of the point 2 and 4 with respect to the line. X minus 1 upon 2 is equal to y minus 2 upon 1 is equal to z minus 3 upon minus 1. Okay, this is the question. Find the image of the point 2, 1, 4 with respect to the line x minus 1 upon 2 equals y minus 2 upon 1 equals z minus 3 upon minus 1. Let q, x, y, z be the foot of the perpendicular. Okay, let m be the, sorry, m, x, y, z be the image, m be the foot of the perpendicular. Let the proportionality constant be r. Then the coordinates of point m are 2r plus 1, r plus 2, minus r plus 3. So DRS of PM 2r plus 1 minus 2, that is 2r minus 1, r plus 2 minus 1, that is r plus 1, and minus r plus 3 minus 4, minus r minus 1, and the DRS of the line are 2, 1, minus 1. So 2 into 2r minus 1 plus 1 into r plus 1 minus 1 into minus r minus 1 is equal to 0. So 4r minus 2 plus r plus 1 plus r plus 1 is equal to 0. So 6r is equal to 0 implies r is equal to 0. If r is equal to 0, then the coordinates of m are 1, minus 1, 1, minus 1. Coordinates of m are minus 1, 1, minus 1. And x plus 2 by 2 is equal to minus 1. X plus 2 by 2 is equal to minus 1. Y plus 1 by 2 is equal to 1. And the z minus 1, z plus 4 by 2, z plus 4 by 2 is equal to minus 1. So x is equal to minus 4. So coordinates of the image of the point are minus 4, y is equal to 2 minus 1 is 1, and z is equal to minus 2 minus 4, that is minus 6. Okay, this is the answer. Then I done distance of a point. Is it clear, guys? Please write in the chat box. Narjo, is it clear? MPC Baripada has joined. Vishwajit. Then I done distance of a point. From a line. Distance of a point from a line measured parallel to another line. Measured parallel to another line. Distance of a point from a line measured parallel to another line. Okay. Suppose this is line L. This is point P. Let the coordinates of point P be x0, y0, z0, and the equation of the line be x minus x1 upon a1 is equal to y minus y1 upon b1 equals z minus z1 upon c1, right? So there is another line L2 is there. So we have to find the distance of the point P from the line L1. This is L1, which is parallel to this is upper line L2. We have to find the distance of the point 3 from the line L1, which is measured parallel to the line L2. Okay. So L2 and suppose this is point Q. The line L2 and PQ are parallel. Suppose equation of the line L2 is x minus x2 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2, right? So since the line PQ and L2 are parallel, their DRSS must be same. So DRS of PQ are A to B to C to DRS of PQ are A to B to C to. So equation of PQ is x minus x0 upon A2 is equal to y minus y0 upon B2 is equal to z minus z0 upon C2. So now we have to find the coordinates of point Q. The point Q is the point of intersection of PQ and line L1. Solving these two equations, we will get the coordinates of Q. Then to find the distance, we have to use the distance formula for PQ. Okay. This is the method how to find the distance of a point from a line measured parallel to another line. So let us read a question asked in JEE 2025. And the distance of the point find the distance of the point 7, 10, 11 from the line x minus 4 upon 1 equals, and the distance of the point 7, 10, 11 from the line x minus 4 upon 1 is equal to y minus 4 upon 0 is equal to z minus 2 upon 3 along the line x minus 9 upon 2 equals y minus 13 upon 3 equals z minus 17 upon 6. Z minus 17 upon 6. Okay. This is the question. On the distance of the point 7, 10, 11 from the line x minus 4 upon 1 equals to y minus 4 upon 0 is equal to z minus 2 upon 3 along the line x minus 9 upon 2 is equal to y minus 13 upon 3 is equal to z minus 17 upon 6. This is the question. So guys, solve it and send me the answer. This is suppose point P having coordinate 7, 10, 11. This is the line x minus 4 upon 1 is equal to equals y minus 4 upon 0 equals z minus 2 upon 3. Okay. And the line, we have to find the distance of the point from this line along the line so equation of this line is x minus 9 upon 2 equals y minus 13 upon 3 equals z minus 17 upon 6, right? So DRS of PQ are 236. DRS of PQ are 236. Equation of PQ x minus 7 upon 2 is equal to y minus 10 upon 3 equal to z minus 11 upon 6, right? So now we have to find out the point of intersection, that is point of intersection of PQ and the line L1. Okay. So let this proportionality constant be R1. So coordinates of Q, since the Q lies on the line L1, coordinates of Q are R1 plus 4, then 4 and 3R1 plus 2, and coordinates of the same point Q according to the PQ. Let this proportionality constant be R2. Then coordinates of Q are 2R2 plus 7 then 3R2 plus 10, then 6R2 plus 11. Right? So 3R2 plus 10 is equal to 4. 3R2 is equal to minus 6. R2 is equal to minus 2. Two R2 plus 10 is equal to 4. This implies R2 is equal to minus 3. If R2 is equal to minus 3, then coordinates of Q are 1, 4. So this is 3R2, sorry. 3R2 plus 10. 3R2 plus 10 is equal to 4. R2 is equal to minus 2, not minus 3. R2 is equal to minus 2. If R2 is equal to minus 2, then the coordinates of point Q are 3, 4, minus 1. R2 is minus 2, that is minus 1. 3, 4, minus 1. So now we have to find the distance. So quickly note it down. 7, 10, 11, 3, 4, minus 1. 7, 10, 11 is 7, 10, 11 and Q is 3, 4, minus 1. So distance PQ is equal to under root 7 minus 3 whole square plus 10 minus 4 whole square plus 11 plus 1 whole square root over 7 minus 3, 4 is 16, 10 minus 4, 6 square is 36, plus 12 is 144, root over, so this is equal to square root of 196. This is equal to 14. Okay, this is the answer. Then come to shortest distance between two lines. The two lines are Q lines. Q lines means non-parallel and non-intersecting lines. The shortest distance between two lines. The two lines are Q lines, non-parallel and non-intersecting lines. Suppose this is line L1 and this is line L2. These are two non-parallel and non-intersecting lines. Let the equation of L1 be x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1, and the line L2 be x minus x2 upon a2 equals y minus y2 upon b2 equals z minus z2 upon c2. ଆସୁ ବାବୁ ଗୋଟେ ପେନ୍ ଫେନ୍ ଅଛି କି? ଏଇଠି ଅଛି। So guys, this is suppose line L1, this is line L2. Look at me, okay? So these two lines are neither parallel nor intersecting. We have to find out the shortest distance between these two lines. The shortest distance between these two lines acts along the common normal, okay? So my finger is the common normal to both the lines. We have to find out these distance, okay? Let P and Q be the points on line L1 and L2 respectively, such that PQ is perpendicular to both L1 as well as L2. This angle is 90 degree and this angle is also 90 degree, right? So let the line passing through the point L1 and L2 with the line L. We have to find out the shortest distance, that is the length PQ, right? Let nearest of the point PQ be ABC. Let ABC be the DRS of PQ. Let ABC be the DRS of PQ. Then, since the PQ is perpendicular to L1 as well as L2, so A into A1 plus B into B1 plus C into C1 is equal to 0, and A into A2 plus B into B2 plus C into C2 is equal to 0. So solving these two equations by cross multiplication, A upon B1 C2 minus B2 C1 is equal to B upon C1 A2 minus C2 A1 is equal to C upon A1 B2 minus A2 B1. So DRS of PQ are B1 C2 minus B2 C1, C1 A2 minus C2 A1, and A1 B2 minus A2 A1. Who will note it down? So DRS of PQ at B1 C2 minus B2 C1 C1 A2 minus C2 A1 A1 B2 minus A2 B1. Okay. This is line L1. Equation of L1 is x minus x1 upon A1 equals y minus y1 upon B1 equals, sorry, z minus z1 upon C1, and equation of line L2 are x minus x2 upon A2 equals y minus y2 upon B2 equals z minus z2 upon C2. So PQ is the shortest distance between the line L1 and L2. This is P, this is Q. So shortest distance. So the shortest distance, so there is a point R on line L1 and S on the line L2. Coordinates of point R are x1, y1, z1, and the coordinates of point S are x2, y2, z2, right? The shortest distance PQ is the projection of RS on the line L. Sorry. This is suppose line L. So shortest distance which is equal to PQ is equal to projection of RS on line L. And you know, if the formula for projection, if PB, PQ are 2 points having coordinate x1, y1, z1 and x2, y2, z2, then projection of PQ on a line L having DCS element, this is the projection, okay? P, this is V. The projection TV is equal to x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into N. This is the formula for projection. So already we have DRS of the line L. DRS of the line L are B1 C2 minus B2 C1, C1 A2 minus C2 A1, A1 B2 minus A2 B1. So from DRS you can calculate the DCS of the line. So shortest distance PQ is equal to shortest distance PQ is equal to x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into n. So LMN are the DCS of the line L. We have DRS of the line L are B1C2 minus B2C1, C1A2 minus C2A1, A1B2 minus A2B1. From the conversion of DRS and DCS, we know if ABC is the DRS of line, then its DCS are A upon under root A square plus B square plus C square, B upon under root A square plus B square plus C square, C upon under root A square plus B square plus C square. So shortest distance SD is equal to, so PQ is equal to x2 minus x1 into B1C2 minus B2C1 plus y2 minus y1 into C1A2 minus C2A1 plus Z2 minus Z1 into A1B2 minus A2B1 divided by under root B1C2 minus B2C1 whole square plus C1A2 minus C2A1 whole square plus A1B2 minus A2B1 whole square. This is the shortest distance. We can express the shortest distance formula in determinant form. The shortest distance is equal to the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by the vector ijk modulus of the vector ijk a1 b1 c1, sorry, a1 b1 c1, a2 b2 c2. So magnitude of this vector. Okay. So, I done a question asked in JEE Main 2025. If the shortest distance between the lines x minus 1 upon 2 equals y minus 2 upon 3 is equal to z minus 3 upon 4 and x by 1 equals y by alpha equals z minus 5 by 1 is 5 by root 6. Then find sum of all possible values of alpha. Find sum of all possible values of alpha. Find sum of all possible values of alpha. If the shortest distance between the lines x minus 1 upon 2 is equal to y minus 2 upon 3 equals to z minus 3 upon 4 and x by 1 is equal to y by alpha is equal to z minus 5 by 1 is 5 by root 6, then find sum of all possible values of alpha. So guys, take 2 minutes of time and solve it. Send me the answer. Okay. Line L1, the second line is x minus 0 upon 1 is equal to y minus 0 upon alpha is equal to z minus 5 upon 1. Okay, the shortest distance is x2 minus x1, y2 minus y1, z2 minus z1. The shortest distance, this is equal to x2 minus x1, 1 minus 0, 1, 2 minus 0, 2, 3 minus 5, minus 2, a1, b1, c1, a2, b2, c2, 1 alpha 1, then 2, 3, 4 upon magnitude of the vector I, j, k, 1 alpha 1, 2, 3, 4 is equal to 5 upon root 6. Okay. This implies, so 1 into minus 3 minus 4 alpha -2 into -2 -4 +2 into 2 alpha -3 divided by root over of -3 -4 alpha whole square -4 -2 alpha whole square plus 2 alpha -3 whole square is equal to 5 upon root 6. Okay. So quickly note it down. I will use the next page. After simplification, this will give you 116 alpha square plus 348 alpha minus 164 is equal to 0. We have to find the sum of all possible values of alpha. Since this is a quadratic equation in alpha, there are two values, alpha 1 and alpha 2. So sum of the roots, alpha 1 plus alpha 2 is equal to minus b by a. This is equal to minus 348 divided by 116. This is equal to minus 3. This is the answer. Okay. Then write down the next question. Let the shortest distance let the shortest distance between the lines अच्छा बैक पेज ओपन प्लीज ओके 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 जस्ट अ मिनट So back page is not available because I have consumed all the pages available. If you want the answer, I will write it again. I am writing it again. After simplification, this will give you 116 alpha square plus 348 alpha minus 164 is equal to 0. We have to find out the sum of all possible values of alpha. This is a quadratic equation in alpha. Let the two values of alpha be, one of the value be alpha 1 and the other value be alpha 2. Sum of the roots is equal to minus b by a and the product of the roots is equal to c by a. So alpha 1 plus alpha 2 equals minus 348 upon 116. And this is equal to minus 3. So quickly note it down. Okay, guys, session is over. Your 3D geometry is over. Your next class is on probability, right?